Hello, Algebra 2. Are you guys ready for your latest installment of rational equations? Today we're going to be solving them, which is not a whole lot different from adding and subtracting. We're just going to add one little extra thing on there, which is this little equal sign, okay? And it doesn't change a whole lot of anything. All right, so the very first thing that we need to do is kind of go over the two steps of solving rational equations. So the very first thing you have to do is find the least common denominator. And again, we've done that. We've been doing that for days with our adding and subtracting, and we're going to do the same exact thing when we're solving. The second part of solving is checking your answer into the original equation. The reason is that we can't have an answer that makes the expression 0 because there's no solution if it's 0. Think about when we do fractions in general, anything over 0 doesn't work because we can't divide by 0, right? And we would call that an undefined answer. Remember when we had slopes and we would say it was undefined or no solution, okay? So once we find what our value of x is, we just want to double check that it doesn't make any of the denominators 0, okay? And right here I said if it makes the expression 0, but basically I actually think that's I worded that badly whenever I said that because we want to make sure it doesn't make the denominator 0, okay? All right. So finding our LCD is not super difficult. Again, like I said, it's just like what we did before, where we are looking at all the denominators and seeing what they have in common, okay? Now, I know that the 10 has a 2 in common, right? Because 10 divided by 2 is 5. So that's pretty simple as far as I could use 10 as the least common denominator for 2 and 10. The problem becomes this little x plus 3 guy here. Yeah, he's kind of trying to come in there and mess everything up. But really, it's not that big a deal because now all we need to do is we need to make sure that in our LCD we have 10 and we have x plus 3. Okay, so now in our least common denominator, it's going to be 10 times x plus 3. Okay, now notice I just put that 10 there. But if I do a 10 there, I have to do a 10 here too, right? Now, I'm going to go to the far right because the 2 is maybe the harder one. If I have a 10 on the right, the thing that I need to put with that is an x plus 3, right? So that I can come up with that LCD. So I simply multiply it. And if I do it to the bottom, I also have to do it to the top. Okay. So let's look at 2. 2 is only a little bit different because it is not the 10 or the x plus 3, but we can absolutely make it that, right? Let me put this over to the side. If I have 3 halves and I want this bottom part to be 10x plus 3, right? Well, to go from 2 to 10, I would need to multiply by 5, right? But to go from 2 to x plus 3, really, I just need to make sure I have that x plus 3 there, right? So if you notice here, if I multiply that 2 times 5 and times x plus 3, don't I end up with 10 times x plus 3? That's what we want. So now since I did that on the bottom, I also have to do it on the top. This 5 times 3 is 15, so it would be 15 times x plus 3. Okay, so, let me put that there for you for reference. We're going to multiply 5 times x plus 3 for that middle fraction. Okay, so give me a second. Let me erase this real quick. Give me a little more room to work. Okay, now here's the kicker. 10 times x plus 3, 10 times x plus 3, and 10 times x plus 3. Do you see that no matter what the x value is in those three denominators, they're all going to be the same? It's as if it was 1, 1, and 1. If that was the case, would we even need to worry about them? No. So we don't have to worry about them here either. We can absolutely, completely, and totally ignore them. Okay? We did what we had to do to make them equivalent, and so now we can absolutely not worry about them. So I'm going to rewrite it as 10 times 2, or 20, plus, remember that's a 15 times x plus 3, and it equals 19 times x plus 3. Occasionally, you can do this in your head. This one was a little bit much, so I just went ahead and brought it down so that I could see it all before I start doing my multiplication. Okay. So now if I go to my 15, I'm going to distribute that and distribute my 19. So I have 20 plus 15x plus 45 equals 19x plus 57. Okay, well, on the left side, I can see that my 20 and 45 can combine to be 65, right? And then if I take that 15x away and put it over here, I can simplify that a little bit further into 65 equals 4x plus 57. And then I simply subtract my 57, and I get x as 2. So out of that entire problem, I have an answer of x equals 2. Okay? Now, the kicker with equations, right? We found the least common denominator. We canceled out all the denominators. We worked the equation. Now, we have to check it. The key here is just the denominators, right? And it's in the original equation. What I would suggest is that, you know, if it starts to get where you have a whole lot of work and it's hard to see the original, just go and highlight the original denominators so that you can go back and check it. It'll also help you remember to check it. The only one that has an x is this guy right here. And if I put 2 in for x, 2 plus 3 is 5. The only thing we're looking for is if that makes it a 0. And it's not. The only number here that could make that a 0 would be -3. So our 2 is just fine. All right. Let's look at our next one. And again, at any time, if you want to pause the video and try these on your own, absolutely do that, okay? It gives you good practice. So we need an LCD, and another trick that I use to find the LCD is I just look, especially when I see all of these things that are the same, right? Like an x minus 2 and an x, I go look at the one that has everything in it, right? This can absolutely be my LCD because it has an x in it and it has an x minus 2 in it. So that's perfect. It's almost like a given, right? We can just totally use that as our LCD, okay? Now, if I want each and every denominator to be this way, I've got to do some multiplying. My x is missing the x minus 2, so I'll multiply that on top and bottom. And then my x minus 2 is missing an x. So I'll multiply that on top and bottom. All right. So let me show you one thing real quick, because now that I have this guy right here, I need to do some distributive property, and there's a negative here, or a minus. Well, that minus, we know from adding and subtracting that we've got to distribute that negative. And so instead of distributing it right now, which could be a little confusing, I'm going to go ahead and do this 4 times x minus 2 first. Okay. And now I can distribute my minus sign, right? Because it has to go to this and to this. effectively basically changing those signs, okay? Now, all my denominators are good, so I can do 3x minus 4x plus 8 equals 18x. So that would be a negative x plus 8 equals 18x. I'll add my x to both sides. Now, again, weird number, you know, like sometimes that just happens, but I want you to realize that that's so not a big deal as long as it works. So we just need to go back and double check it. And this is where you can use some common sense, right? 8/19 is positive. So if I subtract 2, I might get a negative, but I'm not going to get 0, right? The only thing that could make x minus 2 equals 0 is if it was a 2, because 2 minus 2 equals 0. And then here, think about if I was looking at this front x. Well, whatever was in here, the only way that I could make this equal 0 is if that front x was 0, because that's when you multiply something by 0, it's 0. That doesn't apply here, so we're good. Okay. I'm going to do a couple more for you. There's maybe 4 or 5 more examples, and I want to show you each and every one, but I don't feel like we need to go through every single one for this video. But if you have trouble on something, please let me know and email me, okay? All right, so I have to say, guys, this is a fave, okay? This is definitely a favorite because that's the difference of 2 squares. That comes up all the time, and it can be something that is so easy to miss. So the minute you see a factor that is just an x squared and a minus and a number, I want you to always be thinking about the difference of 2 squares, okay? 9 times out of 10, that's what it is. So because of that, this denominator is going to be x minus 1 and x plus 1, which is funny because guess what? That's what we have. So this is going to be our LCD now. And when I go over to the other side, all I'm going to need to do is multiply this side by x minus 1 and this side by x plus 1, which means I also have to do that to the top. Don't forget that part. Okay. Now, I tend to always rewrite these, at least the top part, right? Because my bottom part doesn't matter anymore. I did what I needed to do and I got them all to be common denominators. So now I just need to write my top or my numerator. Okay, now sometimes when it's a negative like that, I like to put it in brackets if I rewrite it, just because I want to remember not to mess up these signs, right? Because you have to distribute that negative. So this becomes 2x minus 2 minus x minus 1 equals negative 2. Well, I've got an x and an x I can combine. 2x minus x is just 1x. Those are gone. And then I have a negative 2 and a negative 1. And then this becomes pretty simple, right? We just add 3 to both sides, and x equals 1. All right. Only thing left to do is double check our answer against the original problem. So again, I think of, you know, if you were to highlight those and you go back up and see it. Now, this one, I already see a problem because my answer is 1. And here, you know, think about 1 minus 1 is 0. So already I know that this is no solution. I can check the other ones, but I really only need one to tell me that it's no solution. But this right side would also be 0, right? Because it's 1 times 1 and then minus 1. So you only need one denominator of 0 to have no solution. I mean, sometimes you'll have more, but just because there's only one time where it becomes a 0, that still just can't happen, right? We can't have this fraction be 1 over 0 because it just doesn't exist. That is not a number we use, okay? And so that's why we don't need to use that one. I'm going to have you do C on your own. And let's see which one I want to do with you. Let's do D. No, I'm sorry, E, okay? Because there's a quadratic in there, okay? Now, we do have to factor that. And I'm going to let you in on a little math secret. In a problem like this, look at your other factors, okay? 99% of the time, these are going to be the ones you're looking for, right? 6 times 1 is 6, and 6 plus 1 is 7. Very cool. So that means that this whole thing needs to be our common denominator. So the right side is missing the x plus 6, and the left side is missing the x plus 1. All right, very cool. Let's work this out. Again, we do not need our denominators because we got them all to be common. Sometimes I will do this part in my head if I can, and so if you can, go right ahead. That would be x squared plus x equals negative 6 plus 2x plus 12. So what you should immediately notice is this x squared term, right? We haven't had one of those before show up in our equation, but it's fine. Let's just keep working through it and see if we can make this happen, right? So I can combine my negative 6 and my 12 to be 6, right? And then I could subtract my minus 2x on both sides to get it over to the other side. But I mean, really, I've got all my x's isolated, but there's nothing I can do at this point to try to solve for x. But here's the thing. The minute that you see that x squared, I want you to immediately think quadratic. Okay? That's a quadratic equation. And we did not spend, forever and a day solving those for no reason, right? We can solve that problem. We just need to make sure that we get everything over to the left so that the right side is 0. We've done that before too, when we first started solving these guys. So that becomes, I'm going to bring it up here, minus x minus 6 equals 0. Well, I know how to solve those. I've got to factor it. So I have a negative 6. Then I need to see what two factors I could use that would multiply to get negative 6 and add to get negative 1. So the thing I think of immediately is 3 and 2 because they're 1 apart, right? And if that 6 is negative, then I need one of these to be negative. So it's definitely got to be the 3 because negative 3 plus 2 is negative 1, which is what's here. Now, we're not quite done. We have 2 more steps. First of all, we have to remember that we're setting these equal to 0 because we want what x equals, right? So, of course, x minus 3 and x plus 2 would give us x is 3 and x is negative 2. So, if we go back up here and look, basically these two are the ones I need to check, right? So 3 plus 6 or 3 plus 1, negative 2 plus 6, negative 2 plus 1. Either way, they're not going to be 0. So both of these solutions work. All right, so what I'm going to do is I'm going to give you the answers for C, D, and F so that you can see if you get them right, okay? And then if you have any questions about how I got those answers, please let me know. X equals negative 4. For D, X equals negative 1/5. And for F, X equals 1. All right, so happy solving. Do those 3. And if you need some help, please let me know.